Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab. So now we are starting this masterclass series and trying my best to finish a topic in one particular session, which will be about 90 minutes or 100 minutes, approximately like that. So now vectors, a topic which is feared by many, and there are good reasons to fear vectors because it seems difficult at first. But let's write down few basic things about vectors. First of all, what is a vector? A vector is a line which has a magnitude as well as direction. Magnitude means it has a length, and direction that will either be shown symbolically or using coordinate geometry. For example, if this point is A, this point is B. So what this vector tells you is that you have to travel from A all the way till B. So one way is going this way in the direction of the arrow. And if you want to break it down, you can break it in terms of horizontal and vertical. That brings us to another idea, and that idea is there are two aspects of vectors. One aspect that is related with coordinate geometry and vectors. So that is one thing that we need to focus on. And the other thing that is about symbolic vectors. So a diagram would be drawn and then you have to work it out. So there would be coordinate geometry and vectors, and there would be symbolic vectors. So let's get started with coordinate geometry and vectors first, and then we will move to symbolic vectors. So now if I talk about coordinate geometry, so let me draw a grid. And one more thing that you can all copy it down later. I'll be uploading the PDF onto a Google Classroom and the video onto the Google Classroom or maybe on YouTube. That I'll think about it later on. So now if this is the origin O, this is the y-axis, this is the x-axis, and side by side we will also be emphasizing on the concepts of coordinate geometry. And let's say this is a point Q. The coordinate of Q is x comma y. Now, if I join origin to Q, so this is known as position vector. So there is a coordinate Q. The coordinate of Q is written as x comma y. And yes, it can be written as a position vector. It means vector with respect to origin. So WRT, it means with respect to. So a coordinate such as x comma y can be written as a position vector. So this is Q. So it can be written as OQ. And like a column vector, this is x, this is y. This format is known as column vector. You write x at the top, you write y at the bottom. So basically, going from O till Q, go x units to the right, go y units up, and that is how you will reach it. Very simple. Similarly, if I write distance from O to Q, so I can write OQ, magnitude, that is x minus 0 whole square, y minus 0 whole square, square root, which is simply x square plus y square, square root. Application of Pythagoras theorem. Similarly, if I write magnitude of vector, so magnitude of vector OQ, that is this thing, the x, and this is the y. So this is x square, this is y square. Add them up and take the square root. In other words, what we have proven is that the distance from O to Q is identical to is exactly the same thing as magnitude of vector OQ. Got the idea? So now there will be some things, some statements I'll be writing in the WhatsApp group, and you can just put a tick mark and emoji over there so that I know that you have understood everything. So let me write over here this magnitude concept, small concepts. I'll go over it. No hurry. Maybe we will finish it in one class. Maybe it will take two classes. So just chill, relax, and just acknowledge. So I hope this magnitude concept is all good, all clear. So now this thing is done. Now what we can do is that I can relate two vectors over here. I can relate 2 points over here. So let me draw a vector like this. And let me label it A. Let me label it B. And A can be written as x1, y1. Let me write it on the sidelines. So A is written as x1 and y1. B is written as x2 and y2. So therefore, this is y1, this is x1, this is x2, this is y2. And going from A till B, so going from A till B, that means I'm traveling from x1 all the way till x2. So let me write this thing horizontally like this. This is x2 minus x1. And this blue one is y2 minus y1. So blue is this one. And the reddish one is this one. Got the idea? So now over here, the vector AB can be written in terms of its position vector OB minus OA. That's one way of writing it. It's always position vector of second letter minus position vector of first letter. That's one way of understanding. Now, some people, they can write it like this also. They can say go from O till A, go from A till B. That's the same thing as OB. So this is the shortcut. AB, OB minus OA. Let me write on the sidelines. So this is the shortcut. What is the shortcut? AB, it's OB minus OA. So we can also see over here, this is x2 minus x1. This is y2 minus y1. So the same thing can be obtained over here. OB can be written as x2, y2. And OA can be written as x1, y1. The difference is x2 minus x1, y2 minus y1. And this is the vector AB. So now that is about AB. And of course, if I give you a sneak preview, this thing, let me first explain it also using Pythagoras theorem. That is, if you are looking for the magnitude of AB, that is x2 minus x1 whole square. This is the base. This is the height. This is the 90-degree angle. This is the hypotenuse. So plus y2 minus y1 whole square, the whole thing under root. So let me just push it to the side a little bit. Okay, that's better. And let me write it like this. And over here. And let me put a square root. So if someone is interested in the magnitude, this can also be written like this. And secondly, someone asks me to repeat this. OA is written as x1, y1. OB is written as x2, y2. That means what is AB? How can you go from A till B? So going from A till B, that is the position vector of second letter minus position vector of first letter. That is OB minus OA. If you want me to draw a diagram, I can also draw a diagram like this. Now let's say this is one vector. This is another vector. And the resultant vector is this thing. So let's say this vector is A, this vector is B. So the green vector, that is the summation of two vectors. the concept of resultant of two vectors. So that is the green one is a plus b. You start, that is the start, that is the end. So that is a plus b. So you're going from this way, that is the end result. Similarly, if you are going from origin till A, you're going from A till B. What is the shortcut? The shortcut is OB. So if you want, I can write it like that. So let me just push this a little bit down. Okay. So I can originally write it like this, OA plus AB. That's the same thing as OB. AB is, therefore, AB is OB minus OA, position vector of second letter minus position vector of first letter, and that is how you get it. And what else is there? If I am interested in the magnitude of AB, so magnitude of AB is x2 minus x1 whole square, y2 minus y1 whole square under root, which is the same thing as distance between two points. So this is another application. So now what I talked about, distance between 2 points, distance between 2 points, let's say A and B is also magnitude of vector, magnitude of vector AB. Got the idea? So just acknowledge it on the WhatsApp group. I hope someone who asked me this question, that's all good and all clear now. Okay. So now let's move on. Now, what else is there? Now, let's say, let me talk about a line. And there are 3 points on that line. There is a point A, there is a point B, there is a point C. The coordinate of A, or the position vector of A, is 0, 1. Position vector of B is 2, 5. And position vector of C is 5, 11. Now, first of all, let me talk about in terms of coordinate geometry. A is 0, 1. B is 2, 5. C is 5, 11. Let me calculate the gradient of AB. That is 1 minus 5 over 0 minus 2. That is -4, -2. That is +2. Let me calculate gradient of BC. That is 5 minus 11, 2 minus 5, -6, -3. That is also +2. In other words, since the gradient of AB is the same as gradient of BC, therefore A, B, and C, they lie on same straight line. And what do we call such points? We call such points as collinear points. All good? So now this is one thing. Let me remove the vector so far. So now we are talking about coordinate geometry. We are talking about slope and all this thing. So now let me just copy this thing, this diagram, take it to the next page. And let me change it into a vector question. So now this thing is there. And now OA, A becomes OA, 0, 1. B becomes OB, that is 2, 5. C becomes OC, that is 5, 11. Let me find the vector AB, just like the same thing. That is OB minus OA. OB minus OA. Again, let me emphasize, position vector of second letter minus position vector of first letter. So therefore, AB is OB, which is 2, 5, minus 5, 11, actually 0, 1. So this is 2, 5, and this is 0, 1. So this comes out to be 2, 4. Let me find BC. That is OC minus OB. Again, position vector of second letter. So now position vector of second letter is this thing. And position vector of this thing, that is this. So now what is OC? OC is 511 minus OB, that is 2, 5. 5 minus 2 is 3. 11 minus 5 is 6. So this is what you are getting. So now we have two vectors. One is AB, the other one is BC. Now, once this is done, can I simplify vectors a little bit more? Yes, I can. And we use a terminology. Let me insert it in the middle. And this terminology is called scalar multiple. So now let me write the concept of scalar multiple. That means simplify by taking a constant common out. So AB 2, 4 can be written as 2 and 1, 2, because I have taken 2 common out from both. BC, that is 3, 6, can be written as 3, 1, 2. Okay. So now AB is 2, 1, 2. BC is 3, 1, 2. Now, if I divide two vectors, AB divided by BC, and this is 2, 1, 2, this is 3, 1, 2, and if the vectors cancel out, and I'm left with a ratio, that means the two vectors are parallel. So if two vectors are parallel, their division will give me a constant. Whether that constant is an integer, whether that constant is a fraction, that is irrelevant. That is the rule. Now, this is something new. I want you to focus solely on this. So just focus on this one. That is two vectors. If they are divided, two vectors, after division, if they are giving me a constant, whether that constant is an integer, whether that constant is a fraction, of course, decimals are the same thing as fraction, that means they are parallel. So now just acknowledge this thing if this is all clear. So I'll just drink some water in the meanwhile. Okay. So if two vectors are divided and they are giving me a constant, the vectors cancel out. That means they are scalar multiple. And I don't know, for some reason, I wrote the wrong spelling of scalar. Let me write it properly, not the whole thing. That is scalar, S-C-A-L-A-R, scalar multiple. That means they are parallel vectors. Now, the same thing was done in two different ways. This is from the perspective of vectors. The same scenario. This is from the perspective of coordinate geometry. Coordinate geometry is related with gradient. Collinear points, they have the same slope. But over here in vectors, collinear points, they will give me what? Parallel vectors. So far, so good. So now that is one aspect of coordinate geometry and vectors. Let's move to something symbolic. Let's say there is a vector A. So let me write this thing as A. Let me just make it even smaller. That is the vector A. And the other one, that is the vector B. And now what I'll do is that I'll be doing some addition, subtraction of this thing. So now this is second type, the second type or type 2, let me call it. So type 2 vectors, that is symbolic. It's not coordinate geometry, it will be diagram based. And over here, this resultant was used in that. And this is type 1, that is the column vector. And this is related with coordinate geometry. So we get started with the idea of column vector. And now we are going to work with symbolic vectors. Now, let me just copy this thing, paste it over here. Let me also copy this thing and paste it over here. And again over here, not the zoom thing. And let me also copy this thing and paste it over here. So I'll be using these vectors. Now let's say someone is interested in adding two A vectors, two blue vectors. That's one vector. That is another vector. That is simple addition. So this vector that I got, that is 2A. Similarly, let me choose this vector and let me add another B to it. So now this is 2B. Now let me choose a B vector and let me add A to it. So either A can be written first, B later, or vice versa. Order does not make a difference. So this is A. It's being added to B. So now start till the end. Start till the end. This vector over here, the green one, that is A plus B. Because this is the start. This is the end. This is addition of vectors. So you add two vectors just like that. So you have to find a root. How can you go from start till the end? How can you find A plus B? You go A, you go B, that is A plus B. Let me again choose this vector A. And let me take this vector B. And let me change the direction. So if B is going this way, then negative B should be going in the opposite direction. So let me just change the arrow. This should be negative B. So now I'm talking about negative vector. Just change the direction. The magnitude remains the same. Now I'm interested in A minus B. But in vectors, it's only about addition. So A minus B is basically A plus negative B. You add the negative vector to A. So that is the negative vector. That is A. That is how you add it. So let me just grab this thing. And let me take it over here. That is negative B. And add A to it. So therefore, A is this one. And negative B plus A can be written it like this. So A plus negative B or A can be written like this. It doesn't make a difference. So this is A. You are adding it to negative B, but it has to look at the direction of the arrow. It has to go down like this. So this is A. and this is negative b. Now follow the arrows. The arrows should be following one another. So remember this term, follow the arrows, arrowheads actually. So now start till the end. This one over here, something like this. So this one is A minus B. Again, have a good look, and then we can proceed from here. So now we are talking about symbolic, we are talking about addition, we are talking about negative vector, and these are the things that we talked about. You can acknowledge it over here. Someone asked about this thing. What if we get one constant only? Yes, that is possible. 2 can be assumed as 2 over 1 or 1 over 2, something like that. That is perfectly good. And let me again, okay, understood. I think that is the thing. Acha ji, let's move on. So now there are some past paper questions that I've taken out. But before that, someone said, can you repeat parallel vectors, please? I'll repeat parallel vectors when we will be talking about a particular question. Okay, so don't worry about that. We will talk about that. Now, before we proceed, there are two things that the examiner gives us. One is called MS, that is mark scheme, which in O-level maths is very, very short. In A-level maths, it's a bit more elaborate, but in O-level maths, it's very short. The other one is ER, that is exam report. And this is something very, very important. So now, before we move ahead, let me read out some important messages because the examiner wants you to understand where will the marks be awarded and where will the marks be cut. So, what are the do's that the examiner is asking you to do, and what are the don'ts? So, keep that in mind. And let me just change this color. Okay. So, now do's and don'ts. Now, this is from which particular year? This is from June 2023, paper 1111 is variant 1. Principal examiner report for teachers. Students should also learn from this. Key messages. To do well in this paper, candidates need to be familiar with the syllabus content. That is very, very obvious. Okay. Be able to carry out basic calculations without a calculator. Why? Because this is paper 1. Understand and use correct mathematical terminology. Maybe they are asking about product. That means multiply. Maybe they are asking about LCM or HCF and things like that. So whatever the terminology is, you should know it. For example, over here, from the perspective of vectors, they can talk about magnitude. They can talk about parallel vectors and so on. Draw and interpret graphs and diagrams. Graphs is not the objective over here. Diagrams, yes, because for vectors, diagrams are very, very essential. Apply mathematical techniques to solve problems, of course. And this is the most important one. Set out their work in clear, logical steps and show all necessary working. So, whatever I'll be showing you, all the necessary working, that should be shown in order to gain full marks. That's one thing. Second thing, now there is something called general comments about the students. Let's read it out also. Many candidates presented their work well with working set out legibly. You can read it. Answers clearly stated on the answer line. So in a paper one, there is this dotted line over there, and the marks are written over there. So like this, and then it says 1 mark. So make sure you write the answers on this line. Otherwise, marks won't be given for accuracy. Most use appropriate geometrical instruments correctly to draw. Maybe it's about a circle, a compass, a curve, and so on, and take measurements from diagrams. Many candidates demonstrated sound basic arithmetic skills, although errors were seen when working with decimals or working with numbers written in standard form. So that is the weak area in that particular paper. Candidates often demonstrated good algebraic skills, although care should be taken when forming equations in the context of graphs or vectors. So that means it should again be something logical. Candidates are encouraged to recognize the difference between expressions and equations. If there is no equal sign, that's an expression. If there is an equal sign, that's an equation. If there is a greater, lesser, greater than or equal, lesser than or equal, that's an inequality. For example, candidates attempt to solve expression by adding an equal to 0 to the end of the expression. Now, this is a mistake that the examiner is talking about. The mistake by students in a particular center. Candidates need to present work carefully and should ensure that numbers such as 147 can be clearly distinguished. And this is always the examiner crying about this. 1, 4, and 7. Make sure they don't look the same. They should cross out and replace work if they have made errors rather than overwriting, as this cannot be read clearly. Some people, they write with a pencil and then they write on top of it with a pen. Don't do that. They should show the method for a question in the working space for that question. If the work continues elsewhere, they should be referred to it in the working space for the question, and then additional work must be clearly labeled with the relevant question number. If maybe, as such, there is no need of extra space. If you need extra space, there will be some blank page. Exactly label it properly. So that is the main thing. Now, let me just go to the question. So now I'm focusing on 2023. 2023, some past paper questions. And let's go to paper 1. Now, sometimes it so happens that they give vectors in both the papers, sometimes totally in paper 1, sometimes totally in paper 2. So there is no set rule. Vectors question, they can come in paper 1, no issue. They can come in paper 2. Yes, if they have given it in paper 1, very high chances they won't be asking it in paper 2. So now let's look at this question. This is May-June 2023 version of variant 1.1. First, I would like you to go through the whole question. And what I can do is that I can send this image to you so you can look at in the group and you have that reference over there. Okay, it's sent to you people in the group. So now go through it once more. And it's everything on one page. So now it says, first of all, it says the diagram is not drawn to scale. So you should not measure it. That's the first thing. The very first thing that they're asking is that OABC is a parallelogram. Now, what is the definition of a parallelogram? Opposite sides are parallel as well as equal in length. So that is a parallelogram. That means AB and OC, they both are equal to 3C. So OC is 3C. That is the same thing as AB, and I have drawn that arrow also. That is the first thing. So no hurry, read question, jot the things down. Second thing, we have this thing, which is 2A. OA is 2A. Therefore, this thing is also 2A. So OA is 2A. That is the same thing as CB. Take care of the direction. Direction is very important. O till A is 2A. C till B is 2B. 2CA. AO would be negative 2A. BC would be negative 2A. Got the idea? So take care of the value and the direction. M is the midpoint of BC. That means, let me just write it because we are learning at this moment. There is no hurry. If someone is asking for CM, that should only be A, and MB should only be A because we are going halfway. C till M, that is A. M till B, that is A. All good? T is the point on OB. T is the point on OB such that OT is to TB is to 1. So let me label it. OT is to TB is to 1. So this is 2, this is 1. That is the ratio. OT is to TB is to 1. If I ask you, this is OT, this is OB, that means OT is 2/3 of OB. So OT is 2/3 of OB. Similarly, TB is 1/3 of OB. Now, the last two statements I have written so far, the last two vector statements that I have written so far, is this all good, all clear? 2 is to 1. The whole thing is 3. So the green one is 2/3 of the whole thing. The purple one is 1/3 of the whole thing. So that is the green one and that is the purple one. This is the purple one. This is the green one. All good, all clear? Now it says find OB in terms of A and C. So now you have to devise a route. You have to go till OB. So you can go from O till C and then C till B. That's the same thing as OB. Listen to me once again. O till C, you take a walk and then you go in this direction to B. Start till the end, that is OB. Someone can ask this question, can we go from O till A and then A till B? Of course, yes. So O till A till B, that is also OB. So now O till A, let me write it over here. So O till A plus A till B, that is OB. OA is 2A. And AB is the same thing as OC, that is 3C. So that is the answer for the first part. Make a habit of writing here 2A plus 3C, 1 mark. Express as simply as possible in terms of A and C. What is AM? Now, how can I get AM? Go from A till B, go from B till M. That's the same thing as AM. Now we know that MB is A. So if MB is A, therefore BM is negative A. Keep that in mind because we are going in this direction. BM is negative A. So therefore, let me draw an orange vector like this, a thin one like this. So now draw as many lines as possible. Draw on diagram. It's all cool, provided you draw with a pencil. So you can erase it easily. So now A till B, B till M is AM. A till B plus B till M, that is AM. What is AB? AB is 3C. So AB is 3C and BM is how much? BM is negative A. So you can write it like this, negative A plus 3C. Negative A plus 3C. I just want a proper way of writing it. First A, then C, first A, then C. Doesn't make a difference if it's negative or not. That's the second thing. The third one is AT. Now I want to go from A till T. So now I can go from O till A till T. That's the same thing as OT. First, write it down. O till O till A till T. That is OT. Don't forget to put the arrowheads. AT, that is OT minus OA. What is OT? OT is over here, 2/3 of OB. What is OB? 2A plus 3C. So this is 2/3 of OB minus OA. Then write this thing as 2/3 of OB. What is OB? OB is 2A plus 3C. 2A plus 3C minus OA. What is OA? That is 2A. Simplify. So therefore, 2/3 of 2, that is 4/3 A. 2/3 of 3, that is 2C minus 2A. So 4/3 minus 2, that is negative 2/3 A plus 2C. And I know this might seem difficult to you people. Let me zoom it out so that you can have a look. So have a good look at last part. I'll just wait. So just acknowledge it on the WhatsApp so that I know that you have understood it well, and then I can proceed. Just put a tick mark over there, a thumbs up over there. And let me also check individual WhatsApp. Acha ji, let's move on. So now the last part. Show that ATM is a straight line. Show that ATM is a straight line. Now, first look at what we have. We have OB, we have AM, we have AT. We have AM, we have AT. So this is like that collinear point thing. Let me write AM again. That is minus A plus 3C. So let me write AM again. That is minus A plus 3C. Let me write AT once more. That is minus 2/3 A plus 2C. Now, can I write with the LCM that is minus 2A, and this is 6C divided by 3. And if I take common a minus 2/3, so or plus 2/3, so therefore this is minus A, and this is 3C. So now 6C, 6 over 3 is this thing. Now just have a good look. What I have done is that I simply wrote AM, I wrote AT, and I took 2/3 common out after taking LCM. Before taking LCM, that's your choice. So now once I take this thing common out, this thing on the inside, isn't that AM? Yes. In other words, if I divide two vectors, AM divided by AT, so that is minus A plus 3C divided by 2/3 minus A plus 3C, I get 1 over 2/3 or 3 over 2. That means if two vectors divide and give you a constant, that means AM is parallel to AT. Therefore, AM and T are collinear points. If they are collinear points, therefore AMT is a straight line. Now, the ending is very dramatic. Listen to this thing once again. All we have to do is to apply this concept of parallel vectors. Let me go up. That's right over here. We were talking about collinear points. We were talking about parallel vectors. We were talking about coordinates. AB is 2 bracket 1, 2. BC is 3 bracket 1, 2. If I take these two vectors and if I divide, if I get a constant, that means the two vectors are parallel. It also means that A, B, and C, they lie on same straight line. If they lie on same straight line, that means they are collinear points. Now let's come back to our particular question. What does it say? It says that AM is this, AT is this thing. What I have done is that I have taken a 2/3 common minus A plus 3C. So let me erase the step and let me write over here that is 2/3 minus A plus 3C. If you multiply it out, it becomes the same. 2/3 into negative A. So that becomes minus 2/3 A. 2/3 into 3C. 3 cancel out. That is 2C. Okay. Now this thing is exactly the same. So this minus A plus 3C minus A plus 3C is exactly the same, just like the vector was the same. If I divide this thing, these two cancel out. 1 divided by 2/3 is 3 over 2. Therefore, whenever two vectors divide and give you a constant, that means they are parallel vectors. That means they are collinear points. Therefore, they lie on a straight line. Collinear point and straight line is the same thing. So now the ending of this question about collinear points, collinear, not collider, collinear, I think the collinear points, straight line, parallel vectors. So this is the climax of this particular question. Is this all got all clear? And also let's check the answer. The first one was 2A plus 3C. The first one was 2A plus 3C. The second one was minus A plus 3C. The second one was minus A plus 3C. They have written 3C minus A. It's exactly the same. The third one was minus 2/3 A plus 2C. Minus 2/3 A plus 2C. And the last one, AM is 3 over 2 AT. So now they have written it like this. AM divided by AT is 3 over 2. AM, if I make it the subject, that is 3 over 2 AT. Or AT is 2/3 of AM if I cross multiply, because AT is bigger. AT is 2/3 of AM. AM over AT, AM is 3 over 2, this thing, and AT is this much. So that is the ratio that you are getting. And AT is parallel to TM, both go through T. ATM is a straight line, the way that I've explained it over here. And let me check EB plus BT. Yes, you can also go it this way. That is good. And those people who are messaging me individually, let me know your name so that I can save your number. Those people who are curious and they ask questions. So I'll be saving those numbers. So now this thing is done. Now this is like the examiner report, the question part of it. Now how they have explained it. So let me underline it. Most candidates who attempted this part gave the correct vector. Common incorrect answers were such and such. Many correct vectors were seen. Some incorrect were this. The best response began by writing down the vector root for the required vector. When we look at the diagram and we define a root, that is called the vector root. Many responses gave the correct vector root, but then did not find the vector, often due to a slip in the signs indicating the direction. And then they're talking about all the mistakes. Part C, few fully correct answers were seen to this part. That means this was difficult. Most responses explained in words why ATM was a straight line and did not explain the reasoning by using vectors. You have to use the reasoning. Some answers correctly showed that AT was parallel to TM, AM was parallel to TM, but did not include the step starting a common point. So in other words, over here, if two vectors are parallel, one vector, let's say u, divided by v is a constant. This constant is called scalar multiple. Or we can say u is k times v. One vector is a constant times the other. That is the same thing as this. Now, let's try out one more question for today. And let me just have a look. This one is more trickier. Let's first get started with this. So now, again, let me share this image with you. Export this page, image. Okay. So now have a good look at it. And I would like you people to first try it out. Take 5 minutes, try it out. Until then, I'm pausing the recording. So now we are back after you people have tried out this question. So let's look at the working. It says in the diagram, OABC is a parallelogram. So now opposite sides are parallel. These two are opposite sides. They are parallel. And the other two opposite sides are this. Let me change the color. That goes like this. That goes like this. Now OA is A. So if OA is A, that means CB is also A. So OA is A. That's the same thing as CB. And then OC is C. That's the same thing as AB. And then X is the midpoint of AC. Where is X? X is the midpoint of AC. Okay, they have not labeled it. So that is X. That is somewhere over here. That is the midpoint. And Y is the point on AB? Y is the point on AB such that AY is to YB is to 1. So that means Y would be somewhere over here. So Y would be over here. And let me just remove the small c from here. And let me write it somewhere over here. Okay. So now this is the thing. That means AX should equal XC because X is the midpoint. And AY is to YB is to 1. So AY is to YB is to 1. In other words, AY is to AB is to 3. The whole thing is 3. So this is 2. This is 1. The whole thing is 3. So AY is to AB is 2/3. And then it says express as simply as possible in terms of A and C, AC. So AC, the first one is very simple. O till A till C, that is O till C. OA plus AC is equals to OC. OA plus AC is equals to OC. Make AC the subject. That is OC minus OA. OC is C, OA is A. So that is C minus A. The position vector of X, it means if I join a line like this, from origin till X, that is the position vector of X. So now I have to make a route O till A till X, that's the same thing as OX. So now I know what is AC. So AX is half of AC. AX is half of AC based upon the midpoint concept. AC is C minus A. So first of all, AX is half of AC. That is half of C minus A. That is half C minus half A. That's the first thing. It's a two-step thing. And now OA plus AX is equals to OX. OA plus AX is equals to OX. OA is A. AX is this thing, which I just found, half C minus half A. That is OX. So therefore, OX is A minus half A, that is half A. And this is half C. So this is half A plus half C. You can also write this thing as half bracket A plus C. YX. How can you go from Y till X? So now let me first find AY. AY from here, that is 2/3 of AB. So let me focus on this. Therefore, AY is 2/3 of AB. AB is the same thing as C. So that is 2/3 C. So AY is 2/3 C. So AY is 2/3 C. And what am I looking for? I'm looking for YX. So now this is the root. AY till YX is equals to AX. Let me draw a line. So AY till YX is the same thing as AX. AY, YX is equals to AX. Make YX the subject, that is AX minus AY. What is AX? AX is over here, half of AC. And AX is also over here, my bad. That is this thing, half C minus half A. That is half C minus half A. Use brackets excessively. Minus AY. What is AY? AY is over here. That is 2/3 C. That is 2/3 C. So this is half C minus 2/3 C minus half A. So half minus 2/3. Half minus 2/3. So I can write this thing as a 6 at the bottom. 6 divided by 2 is 3. That is 3. And that is 4. 3 minus 4 is negative 1/6. So this is negative 1/6. So this comes out to be negative 1/6 C minus negative half A. Negative 1/6 C minus negative half A. And now let's check the answer. So first of all, negative half A, this 24 is not for me. That is for some other part. So crop this thing and just this much. Okay. Okay. Let's double check. I think the last one is correct. That means everything is correct. Negative half A, negative half C. This is correct. This is half A plus half C, half A plus half C. That is correct. C minus A, C minus A. That is correct. So let's stop over here. That is lecture number 1 of vectors. Hope you have enjoyed it all, and I have been successful in making this difficult topic easy for you all. Take care, everyone.